Hi, a very good evening, everyone. Welcome to the first public lecture on the expert series organized by Visiting School Integrated Sustainability and Urban Creativity Center at Asia Pacific University. I'm Dewi, your host and moderator for today's session entitled Harnessing Big Data and Cloud Technology in the Environmental World. Right, you can always drop your questions in the comment sections and we will address them during the Q&A session. Okay, on this blessed evening, we have our talented speaker, Mr. Shervin from High-Tech Padu Berhad. He is a talented data-driven consultant with over 15 years of experience in managing cloud and analytical projects. He involved in the entire process, starting from the conception all the way to the implementation for public and private organizations. And moreover, he analyzed challenges, develop and propose solution to the top management. And at the same time, he ensured the effective communication between the stakeholders and delivery team. All right, without further ado, I will invite our speaker, Mr. Shervin.
Thanks, Dr. Devi.
Hi, Mr. Shervin, how are you?
I'm doing well. Thank you so much.
All right. Okay, the floor is yours, sir.
Thank you so much. Hello, everyone. Very good evening. As I have been introduced, my name is Shervin. I'm from High-Tech Padu Berhad, one of the leading IT company in Malaysia. I've been involved in big data project almost for 10 years. And my forte is more on data storytelling. We have a very interesting topic for you today. It's about harnessing big data analytics and cloud technology, more specific in the environmental world. So let me go through my slide. I have some slides for you for today, and I'll try to finish it within 1 hour. After my presentation slide, we're going to have a Q&A session. So as what Dr. Devi mentioned just now, if you have any question, please post your question in the social media, then we will get back to you with the answers. So let's start with my agenda of this session. First of all, I'm going to have a brief introduction of big data analytics and the importance of big data analytics. And we will talk about data. Basically, of course, when you talk about big data analytics, data is the core and then at the heart of the big data analytics. So we are going to talk about data growth, data preparation, data cleansing, and some of the knowledge on tools and technologies, but we don't go in deep details of the technology. Don't worry about that. For those like they don't really know about big data analytics, I've tried to prepare my slide in a way that everyone can understand the presentation of today. So no matter you have a technical background or not, hopefully going to be easy for you all to understand. We will touch up a bit on architecture and the landscape of big data, and we highlight IoT, machine learning, and AI, artificial intelligence. And then after that, more importantly, on the application and cases of big data. After that, we're going to have some slide on cloud technology, data spectrum, and security. And I will wrap up the session with 2 slides before we go Q&A. Okay. So let's start with data first, big data analytics, and why big data analytics is important. I have gathered some figures for you here, but before we go through the figures, I would say, like, based on my experience, what I have seen, big data analytics being used in every single industry nowadays. No matter we are talking about sustainability, environmental sustainability, if we are talking about business, if we are talking about any other industry in manufacturing, big data analytics always help us to increase the productivity and efficiency, help us to reduce the cost. In terms of the sustainability and environmental concern, help us to reduce the chemicals, protect our resources, reduce the product waste. And when we go to the projects, of course, it helps us from the earliest stage until the end, from measurement, processing, and monitoring of the projects. When we talk about big data analytics in Malaysia, as I have heard, it's about like 10 or 11 years ago that like Malaysia went through big data analytics, and they started to apply big data analytics. And from the report that I have got from IDC, as you can see, the value of market going to be almost $2 billion in near future in Malaysia. So it's a huge market. And 90% of the corporate strategy going to focus on data. And then they mention and acknowledge data as their strategic asset. So 90% on the corporate strategy. And of course, big data analytics as a combustion engine to extract the value from the data going to be one of the competitive advantage of every single business. But there is a big challenge here. Unfortunately, there have been many big data projects fail. I'm not talking just locally, globally. And then that you can see in one of my figures here that I have collected from a few years back, you mentioned like 80% of the projects just remain at the earliest stage, only for pilot project or only for experiment, and didn't go successfully for the production. So 80% is quite high. So in this slide, we're trying to highlight that portion as well. Like what are the challenges and how we can have a successful big data application, more specifically when we talk about environmental sustainability. Okay. So that's where we want to start with data first. I purposefully put one of my oldest slides here. It is from 2010. And the statement you can see there is from Mr. Eric Schmidt, the former executive chairman of Google. The statement talking about the growth of data. And what it says is that from the dawn of civilization until 2003, we have generated 5 exabytes of data. And nowadays, actually that now means 2010, we produce 5 exabytes of data every 2 days. So you can see the huge growth of data, right? So if you want to see what is exabyte and gigabyte, terabyte, I already put it there. So you can see how big is that data. But now let's look at the latest data and information that we got from the report. It's saying that every day by 2025 that we are going to generate 463 exabytes. Let me go back to my previous slide. We were talking about 5 exabytes in every 2 days, and now we are talking about 463 every day. So that is why data is very important, and big data analytics is more important to extract that value from the data, right? So where are these data coming from? I think we all know about the data sources, because for those you are now connecting YouTube or from Facebook, so means that there are huge amount of data every day we generate from YouTube, from social media, Facebook, Twitter. from emails, WhatsApp, and sensors, operational database, from systems. So that 463 exabyte of data actually coming from all these sources. And of course, having different data from different sources, that is where we can figure out where are the challenges of big data that I will highlight it later on with you. Some of the just the statistic and numbers, because the technology when is moving and advancing, of course, then we have more platform, so we have more accessibility in terms of the internet, in terms of the smartphones, then we create more and more data. So that is some of the figures that we have reports globally, and then maybe some if you want to have a look in locally in Malaysia, is like 42 million people now they are using a smartphone, so it's more than the population. So I think now we understand the importance of data. Yeah. So then now we know why they say data is the new oil. This is not new. It's quite some time we are hearing this, that data is a new oil, and big data analytics actually is the combustion engine. Yeah. If you have a doubt, I will give you one example. It's for a few years back, 2016, when Microsoft bought LinkedIn in cash. So 26 billion. And why I put this example, I like this one very much, because to me LinkedIn is a very good platform. It's like is all about data and information of professional or peoples that they share the data and informations in the group, in the chat, in the comments, and it's all about data. So and then Microsoft paid 26 billion for that, because they know they can gain value far beyond this number from the data. Yeah? So that is why data is very, very important. But the question is, if all data are really valuable, all data are really meaningful, so perhaps the answer is no. There are some other data out there which may not be really meaningful, or at least for our application, maybe not relevant. So we have data can be a true signal plus some noise, So that is another challenge actually come into the picture. If like we are talking about big data analytics project and some of the failure, it could be that reason that it's like we have data and data may not be really valid data. Data may not be relevant to us, and even worse, sometimes we don't have data. So that is another important part we have to consider is when we're going through the project of the big data analytics. Let me give you one example. So if we are having like a project and we want to analyze the emissions from different modes of transport, which actually done a few years back in UK. So we want to see like mode of transport means like maybe we're traveling with plane, train, car, or boat. So they are the mode of transport. And for us to analyze the emissions and see which one is like more environmental friendly, perhaps we need to have an air quality index. So we're going to have maybe the sensor can collect those data for us and pass us those relevant data in related to the air quality index. And of course we need to have a number of passengers like traveling with this mode of transport, and perhaps the distance, right? So they are the relevant data, they are the necessary data that are required. But I just put one example there. It's like passengers IC or passport number. Okay, this is it's not a noise. It's very important data, but it's not relevant here. So when I say relevant data, that is what I'm talking about. And who are the people can identify these are the relevant or not? There is like is a joint effort and collaboration between a team in a project. So people should sit down first as subject matter, the people who know the business, who know that domain very well. Let's say we are talking about environmental sustainability. So we are talking about the people who knows this vertical very well. They know this domain very well. So they advise us what type of data that we require if we want to address the emissions, for example, challenge, right? So based on that, then we have to collect the relevant data. So in this case, for example, passenger IC is not relevant, but at the same time, this could be relevant when we talk about, for example, security kind of solutions, right? So that is where data cleansing comes into the picture. One of the very challenging effort, I would say, like in IT industry, people try to avoid it, but it's very hard to avoid it. It's always is there because we we hardly can find the data that they are clean and ready to be analyzed. So there is another challenge in big data that sometimes we don't have a data, as I say, sometimes the data are not clean. There is a phrase that we use more specifically for those they are in business intelligence project. They say garbage in, garbage out, which is very true. So if our data are not clean, data are not relevant, they are full of noise, definitely we can get value from those data. No matter how much we have investment, how much we have invested for software or for hardware or get a latest technology, doesn't matter. So if you ask me one reason like why big data project fail, and I have only option to say just one answer, it's data actually. So it's very, very important. So we have to make sure that the data that we get are the valid data, relevant data, and clean data. So you can see the process of like data cleansing. Usually will be done by data engineer in the project. But as I said, first of all, we have to understand what is the value of this project, what is the business case. So we have to create that case first before we start the project. So we understand that what is the challenge and how big data analytics expecting to address those challenge. So that is where SME and subject matter comes to the picture. And of course, there is a collaboration between them and business people, decision maker, and data science. So once we understand all those things, then we can start to clean up the data. Once the data clean, and then as you can see, some of the process here is like standardization, normalization. Dedupe is like changing the format because data can come in a different format. So we have to make sure that when we have a proper project, proper system, a new system, we have to follow the same format for all this data. And then from there, a proper database to store it. And dedupe is like we remove all the repetitive data, and we keep enrich the data. The more we enrich the data, we can get more value of the data. And one statement below, I think that is very interesting to say what is that brownfield and greenfield development. Let's say we are talking about a new system that we are going to analyze for example, the air quality, and that is a new system. So if we deploy a new system, that one is called greenfield, and we have less challenges compared to brownfield. Brownfield means that you already have a system and you create another new system. Of course, from the old system, the historical data must be migrated to the new system, and it's very challenging. So because these two guys, they are talking in the two different words, and then you have to transform it and change the format from the old one to the new one. But it's the actual work is always need to be done, and in industry we are dealing with all these challenges. So we hardly can find a project is straightforward, all the data are available, valid, so clean, and you just can go to do the analysis. I haven't seen such kind of like system or development yet, unless we are talking about like very small project or when we want to go on a pilot, or on that case, yes, that is a possibility. Yeah. I have highlighted that verify and enrich because I want to also talk about the TIKW pyramid view. And what is that actually is showing us that using big data analytics, we can move from raw data that we have towards the top of the pyramid, which is wisdom. So we go one by one, step by step, by applying big data analytics from raw data, by adding the context, going to information, adding the meaning, we can become like knowledge, and then the insight will become a wisdom. And then this is where we apply big data analytics. simple example I put, you can see at the left side of the presentation. So I put like red, comma, then some numbers, which is the coordinate actually. That is a raw data. By right, raw data may not have a clear meaning when we look at them. But when we add the context to become like information, you will see, okay, that is a coordinate actually is in Charles. And is talking about the traffic light. This is just one example. It's not the actual data. And so it's a traffic light actually in Cheras, for example. And then when we add, we want to have like meaning of that. You say, oh, okay, these traffic lights turn to red. So that red that we have seen in the raw data means the traffic light that has turned to red, and I'm driving towards that traffic light. So what I need to do, I need to stop my car. So this is, as I said, is the insight or the wisdom. So when we decide. So the more we enrich our data with meaning and context, the more knowledge and insight we get out of it. So we can have a better and informed data-based or data-driven decision. So when we say data-based decision or data-driven decision, it's like we should not forget that the key user of big data analytics are the decision makers. At the end of the day, as I say, we want to get value from this data. So this value is for decision makers to apply it in the business, to apply it in that industry, to apply it for the policy for environmental sustainability, right? So based on the data, let's say we want to do planning for the city, or we are talking about urbanization, all these things. So let's just assume we have all this data, and then all this data give us like insight, give us that value that it really helpful for our policy making and for our planning, the way that we want to manage it. Or let's say, for example, nowadays talking about smart cities, all these things. So there's where actually big data analytics can be used. So I think we have now a good idea about big data analytics and why this is important. So we can have big data analytics because it enables us that we can gather, can collect and analyze, process, and store huge amount of data at the right speed at the right time. So that right speed, right time also is important because the old and traditional kind of like technology also could possible to somehow like analyze the data, but very slow. But in some cases, we can't just wait for days or weeks or months. So that's why we can have big data analytics with real-time data. So just assume we are talking about like the quality of the water. It's a drinking water. We cannot figure it out after a month that the water like was polluted and was not clean for drinking. So if we have a sensor inside the water and then this sensor feeding the data live to our system, so we can see the analysis in real time, and then we can make a decision and we can make a right action immediately because we have this data live. So that's why I say it's the right speed and the right time. And then, of course, it can be like different type of data. Sometimes it's coming from sensor, as I say, it's like small feed. Sometimes can be huge amount of data from huge systems, or can be like banking, or can be like just simple file in your database or Excel. So let's have a look on a characteristic of big data. It started with 3 V's quite some time ago, long ago. So talking about three main characteristic of big data, which is volume, velocity, and variety. So it's about like amount of data. Of course, when we say big data, we know we are talking about huge amount of data. And we talk about velocity and variety, the speed, and also different type of data. So it can be structured and unstructured. It's very common. You probably have heard about structured and unstructured data. When we talk about environmental work more specifically, we are dealing with unstructured data. I can say 80 to 90% of our data will be unstructured data. If the data coming from IoT devices, from sensors, or the data coming from the drone that taking picture from on top from the fields, for agriculture and plantation is used, or many other data that is coming from even voice or video, they are all unstructured data. So when we talk about big data analytics, we should not forget we are talking about mainly unstructured data. If it's structured data, sometimes even still simple like systems can be applied and can be used, and we can almost get the same result. So that is where we have to be very careful when choosing the right technology or solution. So after these three V's, then they will be, if I'm not mistaken, IBM add another V on veracity. It's like to make sure that the data are accurate data. So it means that is very important. So we are talking about valid and accurate data. And then after that, another V, which is very important to me, and then for those in industry, because they have seen that many big data projects fail because they focus on technology rather than they focus on value. So that V as value, we have to consider that at first before we start any, or even before we think about big data project, right? So that value is very important. We have to make sure that any implementation at the end there will be a value for us. And I want to add another V, which is visualization. This is also based my experience. It is very, very important, more specifically when we want to pitch our idea to the manager or decision makers, or to the government, for example, if we have for example, new initiative on environmental sustainability. I want to show like how important is that. So the best way is like you get some sample data and then visualize it. When the people see the dashboards and visualize and charts and map, this is where they can easily understand what you're talking about. Even though in the actual project, visualization comes at the end. At the end, once everything is done and in place, visualization will be on top. But for you to prove the concept and to sell and pitch your idea, visualization would be very, very important. So I will have to say like this V as visualization is another V that you have to consider. And if you search over the net, I assume maybe you can find now 10 Vs or 11 or 12 Vs. But to me, those are the Vs that are very, very important. Now let's have a quick look at the architecture of big data. I'm trying to find a very, very simple and high-level architecture, nothing on the technical part. As you can see, in overall, when we talk about big data analytics, we are talking about the data sets can be from everywhere. As I said, it can be from the sensor inside the river that collect the data from water quality, or maybe shows the level of the water, or it can be simply from your Excel file. So these are the data coming from different sources and then with different speed. As I said, some can come in live, maybe some updated daily or weekly basis. And usually we do the process, and for those relevant data, we put inside a database. We call it data warehouse or data lake. That is where actually we integrate data from different sources. And on top of that, we're going to apply all those analytics and dashboards. So when we say analytics and different type of analytics, what are the different types? We have 4 types of analytics, as we call it, analytics spectrum. The first one, everyone familiar with that because it's like the report. It's like telling us what happened. This is descriptive analytics. So what happened is like, okay, it's already gone, past maybe the report for yesterday, last week, or last month. So the next step is like what's going on now, which usually like business intelligence tools comes into the picture and help us to show what's going on now. So, and then from there, we can apply the analytics mainly coming from like big data analytics and predictive analytics, which is talking about the future. Based on the historical data, then we can come up with the modeling, and then we can say, okay, based on this data, this is what we can expect in the future, right? So let's say we are talking about the river and flooding, right? We have historical data, and then we come up with the relation between the level of water and waterfalls, and of course the area that we are doing our study. So based on those historical data, most probably we can have some prediction that is like, okay, with these kind of elements and the factors, most probably we're going to have flooding at this area at that time, so, something like that. So that is like predictive analytics. And then the last one is prescriptive. It's when subject matter expertise and the domain knowledge comes into the picture to give us recommendation, because the other parts could be like, okay, we have done all this analysis, we can see all these charts, and so what. So to answer that, so this is where we do the prescriptive analytics, and this is where actually the machine learning and AI can come into the picture, and also they can learn and give us the advice and help us for the next action. So what's in the future? So then have a look at the big data landscape. I put again the old one first in 2012, showing the software and application they are related to big data analytics. And then from there, you can see in 2021, which I can just see that 2021. I cannot read any of those software or application. The reason is like this landscape, it keep growing. And when it's growing means that there are hundreds of software and solution and hardware coming to this industry. So that would be another challenge. But the thing is that if we understand what is the value we are looking for, what is the business case, what is the challenge we want to address, then choosing the software or hardware wouldn't be that difficult. So that's why I don't really want to focus on this part. Nowadays, for every single application, you're going to have a different option that you can choose, and more or less they are very similar to each other. But first of all, you have to understand what is the business case that you have, what is the problem, and how you want to answer those problems. Then you come to choosing the right tools. So as you can see, is machine learning and AI and data landscape all together. So I have one slide for definition of these two guys. Later I will show to you. Just want to recap on the challenges, because this is very, very important. Because this is from our experience in the industry that we have seen many big data projects fail. And as I just mentioned earlier, it's like, to me, the first could be the data. Unfortunately, sometimes we have everything in place, but we don't have data. So having data, collecting data, getting the right data, and integrating data from different sources, because sometimes even when we talk about like public sector, usually departments, agencies are not willing to share the data. So that is another big challenge. If we have more data, as I say, we can enrich the data and we can get more value. So then from there, they have other also challenges. Of course, choosing the tools or softwares and the security, there would be other challenges, but they come after that. So going back to the AI and machine learning, so they are very also interrelated to big data analytics. Actually, big data analysis make these guys to come into the picture in the industry, because now we can harness the data, and then now we can apply AI and machine learning. It's like when we say AI is the capability of a computer system or the machine to mimic human cognitive functions. It's like they think or act like our brain. So the way that we learn and we solve the problem. And machine learning is a subset of AI, and it's like the way that implement or apply AI. And machine learning has another subset, is like deep learning and neural network. They are like too technical. They have their own expertise. So now let's get to the application, the most interesting part. So now I think we have a good understanding of big data analytics, AI, machine learning, and we have understand the data. And we have seen the application of big data analytics everywhere around us. And we are living with these guys, actually. Every day, like we are dealing with Google, Waze, buy from Shopee, watch video from Netflix. And they are very successful because of big data analytics, AI, machine learning. So if they suggest me what is the next video to watch, or suggest me what item to purchase, or even what route I need to go choose, is all because of big data analytics, AI, and machine learning. So it's like they harness the data, the power of big data, and from there they come up with a recommendation to us and make our lives easier. Looking into environmental sustainability, so first I would like to share one of the cases that I have been involved, but at the pilot stage, a couple of years ago with two of our partners. They are providing Baladati IoT, they are providing big data and IoT platform, and another partner, Bosch, that they provide this, the dongles. Inside they have like almost 9 or 10 sensors. They are best in terms of, they are one of the best in terms of the devices, especially for automotive. So you can see that the picture there is like very similar to the actual dongle. Then it can be plugged inside your cigarette lighter socket inside the car, and then connected to your phone to send the data to your phone, and using Bluetooth, and then from the phone using your data to send to the cloud. But what type of data actually they are sending is very interesting to say, like this guy is actually analyzing the way that you drive. So the guy is like driving behavior analysis. So not only we can analyze the like one of the example I showed earlier, all those YouTube for analyzing viewer, or even for games, analyzing the behavior of gamers. So now even we can analyze the way that we drive. You can see some of the example: hard braking, hard acceleration. So, and then the ultimate goal is supposed to be like the portal accessible by the public, so everyone can see the scores. Because this is not a confidential kind of data, if there's no name, so no one knows like who is this driver. So it's like the scoring, and then encourage people to drive safer. So, and more specifically for fleet managers, like so they can monitor the drivers. So that is like means higher safety and reducing the petrol consumption when we have safer drivers. And that is where actually can support the green economy. And of course, less accidents because we are monitored, and every single our actions in when driving being monitored. So that is one of the example of big data analytics and IoT. I would say another example, which we may be closer to environmental sustainability and how supported is Penang smart parking solution. Again, this solution also built by our company and now being used in Penang. For those who are watching us from Penang, or they have traveled to Penang, they most probably they have been used this application. So this another example of using IoT and big data, and this is the Malaysia first ever smart parking system that using IoT and cloud. What I'm saying first ever, because the other application that we have in the market, they are more like only like e-wallet, this for payment. But smart parking in Penang is the IoT project. As you can see, the sensor, they are in-ground sensor, ground-mounted sensors that they can identify the available parking lots for you. So you can figure out where are the parkings available, and then you can go. Even you can book, and you can straight go to the lot. And then you when you are there, if you look for the other available parking, they can advise, and then you recommend you where is the nearest available parking lot. So this is a very good example of having big data analytics and IoT, and that is like a good sustainable opportunity. I got one report from UCLA in 2017, data from US. They say 30% of traffic congestion is caused by vehicle looking for parking lots. So means, and I believe every one of us can understand that. It had been sometimes like we go round and round and round to just look for available parking. And then from when we say 30% is quite high, and from the same country means US, if you see there's a substantial impact on emission. Based on that study, 3.1 billion gallon of gasoline wasted because of this congestion traffic congestion. So 30% is about almost 1 billion gallons of gasoline. So it's a lot. And I like this example. It's not just because it be developed and deployed by our company. No, it's because we can see the difference when big data analytics and IoT comes into the picture. Because earlier than this, there are many others application that is like mainly on, as I say, is like the e-wallet or just for payment for the parking. But when we apply IoT and big data analytics, so we can identify where are the parkings are available, and then I can go straight to the parking. Other than that, would be the same as the others. Then there is no point. It's not really helping our environment because I still need to go round and round to find the parking. Once I find the parking, then I just pay for that. But using IoT and big data analytics, you can see how we help to reduce the emissions. And this is just for Penang. Hopefully, if either our company or the other company, I know there are many other capable solution provider out there. If we can expand it the whole Malaysia to see how really can impact in our environmental sustainability, and reducing the emissions, just by applying this smart parking. So it's good for city council, good for the driver, and good for our environment. So I have another example for you. So the previous one was in the production, is being used. You can even download the application from Google Store. Another example that I have for you, it's again is more on the pilot and preliminary stage. It was like a couple of years ago. What we did, and I was involved in for one of our city councils in Malaysia. So they have challenges on maintaining the tree and landscape. So that was like the idea. I like to build in the application to first of all collect the data because the issue is like they didn't have the data. So first of all, they have to collect the data, and from there the list of activities for the maintenance. So once we get all the data and then integrate it with the other data from different sources, then we can go in the level even for prediction. So it means that in this case, when we say prediction, means predictive maintenance. So rather than do the traditional way of maintenance, we can have predictive. It means that if I regularly go to that area, for example, once a week, maybe some places I need to go twice a week based on the data, so I can't just wait to go once a week only. It's not enough. So predictive analysis, there is like, okay, you have to go twice a week, then if you want to prevent a disaster, for example, So that's where predictive analytics came into the picture. So I capture some of the screenshot from the old system for you. This I can share with you because it's just like a sample. It's not the actual data. And you can see this is the way that we do the data collection. As I said, the data collection is one of the most challenging part. But the good part is that the city council know that they have no data. So it's like we have to start to collect the data. And then once we collect it, then we can do our activities. So the people on ground, they go take a picture, and the location can be detected from GPS, and then they do whatever activities that need to be done for the maintenance of the tree. And if any incident happen, like lighting, like maybe accidents, the car like crash to the tree, so they will be all logged there. So then from there, as I say, collecting all this historical data, at the end we can apply big data analytics to have the predictive analytics on top of it. So these are some of the projects I've been involved by myself. There are many other examples out there, especially in Malaysia. The good part of it is like, fortunately, when big data analytics came to Malaysia and get like kind of like popular among the players in the market, Ministry of Energy and Natural Resources, and that time was NRE, Natural Resource Environment, one of the key leaders of leveraging big data analytics. And that is very interesting, and it's very good to know that. And they have come up with like number of tenders that are asking for solution provider to come up with the solutions to build the big data application framework. And the good part was the people actually there, they understood they knew what were the problems, and they created the business cases first, and they come up with the business cases and the challenges, and they know these are the challenges that they have, and then ask the IT people, professionals, and then solution providers to apply those technology and big data analytics tools or solutions to address those challenges and answer those challenges and solve the problems. So that was the very, very good approach, that they have identified all the problems, and even for every single tender they have asked for subject matter expert that is compulsory and must be inside the team, which is also another good point. For big data project, as I mentioned many times, this is not about the technology or tools. There is a like joint effort, a collaboration effort, activities that is from business, from subject matters and domain expertise, and of course the technical people, right? So some of the example I have put it here. You can see from land department in decision. I have highlighted some of the keywords to tell you like what are the cases actually. Like for example, water and climate change. We talk about like water quality, wildlife conflict, which I was involved in at the very early stage to figure out how we can monitor and track the wildlife, like elephants, like so that's very challenging, especially when we talk about rural area, remote places. It's very, very challenging. It's not easy because we have no network, and then we have to figure out how we want to track, how we want to collect data, and from our sensors or devices, how we want to transfer the data to the main system, for example. And then some other points that I have highlighted. I have highlighted the integrated database repository, which shows that they understand the issue that data may not be there or may be there, but it's not integrated. Or we don't have a repo or data warehouse to integrate all the data together, right? So this is another initiatives that another example of big data analytics in environmental sustainability. And I know one of the other project just recently go live, and if you go to the website also, you can see the old one that have been done. You can see the dashboard about like wildlife conflict, if I'm not mistaken, is already in the website available there. You can see over the dashboard and all the data. You can play around with the data in the dashboard. Okay, so that is some of the cases that an application that we focus on, of course, the environmental concern and sustainability. Another good example is smart city. We have heard a lot about the smart city. I think we don't need to talk about the smart city, but that is very, very good initiatives, and all all been can be done because of these technologies like BDA, AI, and IoT, and of course cloud. And in this case, I can say Malaysia is like moving towards that, and one of the leaders and the champions is like Putrajaya, and thanks to PPJ, Perpadana Putrajaya, they are like the champion on smart city. So the smartest city, then you can say they are moving more into the environmental sustainability, because the technology help us, for example, reduce the waste, increase the efficiency, going toward the smart energy, maybe solar panel and solar energy, in terms of the safety of the city. And when we put that sustainability at the heart of the smart city to become a smart, sustainable city, this is where we are looking for, and then we are going to. In terms of the AI, I need to highlight one term that is like introduced by, I think it was World Economic Forum, Safe AI. It says we have to make sure that when we apply AI, this AI and evolving of the AI in the system remain friendly, and must be incorporate the health of the natural environment as a fundamental dimension. So when we apply AI, big data analytics, at the end we have to make sure that environmental sustainability and sustainability development in overall and general, it should be at the heart of these systems or application. And all will be, as I said, connected through cloud. So I think now is a good time that we can talk about cloud computing. So I go quite fast forward for the next slides. So cloud computing, very simple definition is like we go on pay-per-use model. If we go on subscription model, so rather than we purchase the software or hardware, we just subscribe, we rent. So there's a very simple explanation, and the good part of it is like you can scale it up and down anytime you want. So it's go on the OPEX model in terms of the commercial part rather than CapEx. So, and nowadays, because we are talking about connecting data together and big data analytics, and then we are talking about the huge amount of data and data growth. So cloud comes to the picture and help us. Just assume if we have some data and then data growth is just maybe 1 or 2% in a year, so maybe we don't really see the value of cloud. But when we are talking about big data analytics, and I showed earlier the data growth, so within like 2 or 3 years, how much data can grow. So definitely in that case, for example, cloud is something that we must look into that as a first option for us. In terms of cloud services, we have heard about IaaS, PaaS, and SaaS, infrastructure as a service, platform as a service, and solution as a service. They are like different ways. For example, if you have a website, you want to host it, it will be just IaaS, or you have like platform that you want to build your application on top is a PaaS, or there is a software is already there in the cloud and you just subscribe and start to use it. Then it will be SaaS. There are a number of cloud service providers out there, but the main one, the key public service provider, public cloud service provider are here. And you can see the names, Microsoft Azure, AWS or Amazon, IBM Cloud, Google Cloud. And they are also very active in terms of the environmental sustainability. They really support it. Google by itself, they have a lots of application. And when we talk about like environmental work, they have a tremendous number of applications that help us. Even those like there are many of them like free, then we can get information data from them. And Microsoft Azure as well, they have the AI for Earth. So they support organizations that they are applying AI to environmental challenges, so then help them, then you can get some services even for free. So of course you can explore that one. You can get the detail from each of these guys, and then to figure out what are the services that they have, which is relevant for you. In terms of services, there are many services out there. Sometimes maybe you need to just host your application. Sometimes maybe you need backup services from them, AI or machine learning services, and many others. So there are like hundreds of services and application and cloud. So you have to figure out which one is more relevant to your case to be used. Okay, there is another interesting topic when we talk about cloud, which is about cloud deployment. We have three model of deployment. One is a public cloud that I just mentioned earlier. Another one is a private cloud, means that you still go on the pay-per-use model or subscription model, but the infrastructure hosted on your prem or within your country or within your data center. So it's not like public cloud that you may not know where are your data. And there's something in between hybrid cloud. Sometimes some of the application can be in public cloud and some in private cloud. How to choose it and why we need to understand all these things, because sometimes when it comes to the data residency issue, especially when we talk about private data, so we have to understand that some of the government do not allow you to just simply deploy your system or application and put your data in public cloud if it's confidential, and private data must be resided privately or within the country. So that is a way that you can figure out which one is the best for you if you go public cloud, private, or hybrid cloud. So when we talk about data residency and type of the data, I think now is a good time to talk about data spectrum. Data spectrum is about like moving from closed and very confidential data towards open data. So they say like we talked about the size of the data earlier. It's a small, medium, and big data. Right? So now we are talking about confidentiality of the data. Some data, they call it open data, so publicly available, and you can make use of those data. So there's no issue on the security because it's already available for everyone over the net. But some is like they are confidential. Let's say we are talking about like IC or maybe information that we have in the bank. They are closed and very confidential data. So definitely you cannot simply put all those data inside the public cloud, for example. So that's why I think it's good to understand what is the data that we are dealing with. Even when we talk about environmental sustainability, always we have also data coming from public, some data are publicly available. Maybe we get some data from Google Maps or Google Earth. So there's no issue in terms of the security, but still we're gonna have some data that is coming from the internal systems that is not can be simply shared with the others, or is actually the property of your company or university or your agency or ministry. So those are the data that also need to be definitely be secure. So that's why we need to know this data spectrum when we talk about security. So which I have another slide, just one slide for security after this. So one example on this open data is a data.gov.my is by Mampu, is an open data platform from the Malaysian government. The first phase done by our company, we have also been involved in that project. And I remember it was, I think, 2014, that there was a big data application challenge, BDA challenge by Mampu and MDEC. And I was one of the finalists there. So I used the data from open data platform. I got the data from dengue cases and also the rainfalls. And I did some analysis to show how rainfalls and dengue cases, number of cases in different area or district can be interrelated together. So this is very interesting for those like they are interested to do the project. Either you are a student for your university project, or you are business owner, or your employee, you want to, or just like data enthusiast, if like you like data and you like play around with the data. So that is kind of like platform that is from different agencies and ministry that then be shared, and you can probably use of those data. So there's no issue in terms of security, as I said, because it's publicly available, it's open data. But in overall, big data security is very, very important. We have to consider that because, as I said, again, sometimes we are dealing with some data, they are very sensitive data or confidential data that is like we have to consider security for our big data projects. So security by itself, to be honest, it's a vast area. We can talk another 1 hour only on security. So I just have one slide here to make sure that no matter we are talking about like data from public or maybe geo data, or maybe we think about environmental sustainability, most of our data may be coming from third party or outside, but still security is very, very crucial and important, So, and then we have to apply security and practice in place to protect our data and the whole system and whole environment. So I'm moving toward my last 2 slides. I'm just going to wrap up the session, the presentation slides. This is actually my takeaway for you all. Especially when we talk about sustainability, environmental sustainability. This is a new term. It's been recently, we hear a lot, and it's going to hear more and more in near future. It's about purpose-driven businesses. Purpose-driven businesses say like every single business, if they want to be profitable and want to be successful, they have to have a purpose, and that purpose goes back to sustainability. There is a study has been done that it shows like majority of those purpose for these purpose-driven businesses or the companies, they are somehow related to those sustainability development goals by United Nations. That's 17 goals that we have. And fortunately, the climate change and climate concern is on top of the list. So what I'm trying to say is like we are moving towards. I'm talking about the business perspective. We are moving towards like embracing sustainability in a way like if not, then we won't be relevant in the business. We won't be relevant in the market anymore, and we even cannot have a profitable business. So sustainability is not anymore is a CSR. Is main objective of the existence of the business. So this we are moving towards that. So if we don't embrace it, we don't understand all these concern, definitely we won't be relevant in the industry in next 10 years. And we will see more and more companies coming on this purpose-driven business. So if you are planning to set up your own business or you are planning to expand your business, you must consider this purpose at the heart of your business and industry. So that was my takeaway for today. And don't forget, please, if you want to start big data project, never start it and never lead it with the technology. You have to understand what is the value, create the business case, put the purpose in the middle of it. And from there, once you create the business cases, then you can go through the technology and choose the right platform and right solution for you. So that is my last slide. Thank you so much for your attention and patience. And I will pass the stage to Dr. Devi.
Thank you, Mr.
Over to
Shervin.
you. My pleasure.
All right, so this is indeed valuable knowledge sharing for us. And you have discussed the key concepts and challenges and applications of big data and cloud technology in different industry, and together with its application in the environmental sustainability. Thank
Yes.
you. Right
Yes.
now, so we shall address some questions from participants. All right. So we receive some questions. Okay, now let's address one question from Mr. LV. All right. So, okay. How do the data engineers protect our data or avoid data leaking from people who are planning to do some illegal activities? Sir.
Yeah, sure. Very interesting questions. Okay, basically, when we talk about security, one is about the systems, the tools that we are using, the environment. So there are many tools out there, and then of course we should not forget that the technology advancing and growing at the same time, the risk also growing and advancing with that. So there is no like 100% secured system out there. But the question is very interesting because this is more on the people. It's not about the tools or the platform. Say like if you want to share the data. So I would say, okay, first of all, we have to understand why we need to share our data to someone else or the third party. So in the industry, what we do, let's say we want to do the project, we always start like if you want to do a smart, very small size of project, we always do like the sample data. So we have to go from sample data first, and then after that we go to production. Then we, of course, if it's needed, we have to share the production data. Then we sign like NDA. So there should be a process, a proper practice, an agreement between the companies or the people if we have to share our data with someone else. Because at the end of the day, as I said, this is nothing about the technology. It's about the people. It's about that person that we trust or not. So, and then we have to identify who are the right person and the only person that must get that data. Because let's assume if we share data with 100 people, and then let's assume we can just share with one person. So if we one person can get the data, so the risk and vulnerability can reduce like 99%, right? So that's like we have to identify who we are dealing with and why. But again, it's something that might happen. We have heard lots of news from big service provider out there, big giants, even those public cloud service providers I have mentioned, they have also that issues when it comes to the people. So I would say again to have a proper practice and the process and understand who are the people, what are the objectives, and perhaps the agreement or contract that we have with the people.
Right. Provide the right data to the right people, yes?
Yes, exactly.
All right, thank you, sir. Now, next questions. Some question from Mr. Kwan. There are three questions. Okay, what is the best cloud service provider in your opinion, and when to use cloud services and big data management? And the last one, what is your view on the role played by data scientists in managing big data?
Okay, thanks. Okay, thanks for the questions. Okay, the first one, for sure I cannot give any name. I mean, it's not because I don't want to share, because we really can't simply say this cloud service provider is the best. As I have mentioned in my slide, we have to understand what is the objective, what we are looking for. Sometimes maybe you are dealing with critical data and very confidential data. You are not even allowed to go to public cloud, and you have to choose private cloud service provider. Like, for example, us, we have a private cloud. So then that is like you are not even giving any chance to all the public service cloud service providers. So we have to see what we are looking for, what is the objectives. And these guys, to be honest, more or less in terms of the cost, they are almost the same. In terms of the services also, more or less they are very similar. So it goes back to your expertise, which one maybe you have more skill set within your team. They are familiar with which of these platform to choose. So that's where always we look into that. That's why from our company, for example, we are partnered with all these cloud service providers in the market, for example, because we know each of them, they have their own capability when it comes to the project. So when to use the cloud services, as I say, if you see, we don't need to purchase the products, we don't need to purchase the software or infrastructure. We can just rent it. We can just subscribe to the service. More specifically, when we are talking about like pilot project or a small project, that rather than do the investment. So short term, definitely no way that you want to go on capex and purchase all these products and tools. You can just go on subscription models. So same goes back to the big data. I mentioned on big data when we are talking about how big is the data, where we go and apply. I think that one I already addressed in my slide. And the last one is the data science. Okay, that is very interesting. Data scientists, they have a very, very crucial role in big data. It's not about managing the big data. They are more involvement is on the building the cases, understanding those business cases and value, and to help us and technical people to figure out where are the data and what are the data need to be collected. They are the people look at the data and tell us what we can do with the data. So in that case, they have a very, very crucial role. But in managing big data project in the industry, we always have project manager, project director to manage all these people. So it's like data science or data engineers, or we will be part of the team.
Right. Thank you. All right.
Yeah.
So now let's proceed to the next question. Oh, this is from Dr. Steven. All right.
Yeah.
So how is big data being applied to the environmental sustainability effort? Go ahead, sir.
Yes, thank. Okay, actually, that was like it was like something I was trying to convey that message towards my presentation slides. When I started until the end, it's like how and where big data can be applied. So I have given some examples. The most important one is like big data actually have enabled us to protect our environment way better than before. So that is very, very interesting. And on top of that, the last few slides I just mentioned that is, as I said, when we talk about environmental sustainability, to be honest, even for kind of people like us in maybe the industry, maybe it was like more on like good to have or CSR activities. So now having big data analytics, we can see how we can leverage on that. Even we can be a profitable business when we are focusing on environmental sustainability. So it's like it's a vast application of big data everywhere that we can apply when we are talking about air quality, water quality, when we talk about waste or garbage collection. They are the actual cases actually being used, which is related to our environmental sustainability. And then the smart cities, and there are many others, as I highlighted again on the sustainability goals, that they are all can be enabled easily by applying big data analytics. I hope I can answer this question.
All right, thank you, sir. Right, one thing that interested from your slide just now is that you were saying that data itself is one of the biggest challenges in analytical projects. Yes. Now,
Yes.
regarding this, in your view, all right, how do we tackle the challenges to collect and reconcile environmental data? Because the fact is that this data come from different sources, isn't it? And
Yes.
often in a variety of different local format. So how can we tackle this challenge?
Correct. Yes, that yes, very interesting question, Gay. Okay. Yes, data always been a challenge, and when we talk about especially environmental sustainability, because when talk about environment, we are talking about woods, we are talking about rivers, and they are like as I said, it can be in a remote area, so there is no connectivity maybe there. So that's always been a challenge to collect the data. But once we identify the cases and once we know what are the data that we are looking for. So as I say, one of the ways is like public data or though data is available publicly for from or third party. Some are the data that we can apply and get from the government, and hopefully, these are the data that, of course, that we need. They support, and when it comes to applying the sensor, of course, that is like we need to have a proper infrastructure. So the thing is that the good part is that once we identify, okay, I give one example from Minister of Energy. So there's like natural resources. So when we have that framework on big data, so we understand where are the challenges, where are the issues that we have, and then we have to come up with a proper infrastructure. So that infrastructure must be in place first, to collect the data. But nowadays, there are many other ways, like for example, applying drones, because they are again actual cases that some area that is like remote area we cannot collect data. Then we use, for example, drones to collect the data, and then from there, then we can transfer the data to our system. So I would say it's a journey. I can say like now is everything is ready and then we can have all the data, but we have a great advancement and is far better than before. And then in that those figures and numbers I show in my first few slides, that's like number of a smartphone, social media, because there are lots of incidents now being reported by the people through social media. We have done one project is more on incident management from flood management perspective, and the people could report those floods through the social media, and the crawler can get the data and put inside the platform. So that is where I say when we have more kind of this technology can help us to gather and collect more and more data. But still we are in the right path, we are moving towards that. It's not something that can be done in this year or next year. Is a journey, but we are moving very fast towards that.
All right, right. Thank you. There is one interesting question here. All right, from Alvi Lim. Okay, so does VPN service company has access to our data, such as our IP address? Very interesting. And again, this is about the data privacy, data protection. Go ahead.
Uh, okay, it's maybe not so really related to big data, but I can say if they want, yes, they can access to can access it. But the thing is that accessing data is one thing. Because let's say, let me give one example from our company. We are also cloud service provider. There are many large organizations, banks, and government. They host their application and data in our data center, right? So if we want, we can access, but we don't do it. We are not allowed to do that. They are not our data. So technically, accessing data or the access IP is one thing, but whether they do it or they do it now or they want to do it, that's another thing. So definitely, if something is belong to us, no one else are allowed to access or they allowed to even touch the data. So there's the same thing goes to us. Again, as I say, when we talk about the proper practice, best practice, the process, the agreement, all those contracts when it comes to the picture, so that is where we can save ourselves.
Right. Okay. Right, so we have another question from Dr. Steven. Okay, so it's quite long, impacting environmental sustainability, while other sectors are experiencing revolutionizing effects. Go ahead, sir.
What big data is impact? To what extent big data is impacting environmental? Okay. Um, I think it's very. My answer would be very similar to my previous answer. It's again to me, sustainability, the involvement of big data and AI and technologies to me is like created a new era for sustainability and environmental sustainability. The way that how we can leverage on all this data and to protect our environment. Uh, so so that is like again, as I say, it's like I can say like in the near future, environmental sustainability will be the key objective of having all this technology. So we are even moving towards that. So that journey going way like the first objective of having like all this technology, AI, big data will be about sustainability. So that is I can say that it's like how important this big data and how can impact on this environmental sustainability in the future.
Right. Yeah, definitely. We can utilize big data to predict and reduce the impact of some natural disasters, as you said, for the flood case study. Right.
Yes, yes,
Okay.
yes, yes.
So, yeah,
Yeah.
I think let me check once again if we have more questions. Right. Yeah, I think that's it, sir. Thank you. All right. So this is indeed a valuable session, and I think we are now going to end our session. Okay. And on behalf of the Integrated Sustainability Integrated Center, right, I would like to say thank you, Mr. Servin, for making time
My
for
pleasure.
this type of lecture. Right. And thank you for all participants. We will see you again on the next public lecture in Expert Series. Bye bye and stay
Thank
safe.
you. Bye bye.